This is the Precalculus mid-4th 6 weeks exam of 2019. 20 problems here. We'll go over these one at a time. The measure of an angle A in DMS units is 46 degrees, 45 minutes was the measure of angle A in degrees. Well, for that, we're going to take 46 degrees plus, we're going to take this 45 minutes, and to convert into degrees, we're going to divide by 60. And when we do that, we're going to get 46.75 degrees. And it should be logical in that you have 45 minutes as 3/4 of an hour, and similarly 45 minutes is 3/4 of, or 0.75 of a degree. So C is our correct answer for this one. Problem 2. The measure of angle B is 135 degrees. What is the measure of angle B in radians? Well, for this we have some choices. One thing we can do is, if we understand that 180 degrees is equivalent to pi radians, we can take we can take 135 degrees and multiply it by pi radians over 180 degrees. And when we do that, we're going to get 3/4 pi radians, or pi over 4 radians. Now, another thing, if you use the unit circle, we should be able to see that here in the blue we have the degrees, and in the red we have the radians. So 135 degrees is equivalent to 3 pi over 4 radians. Okay, let's go on to problem 3. The measure of angle is 7 pi over 9 radians. What is the measure of the angle in degrees? Okay, obviously we're hitting this pretty hard. One of the key student expectations here. So we're going to take this 7 pi over 9, and that's going to be in radians. And anytime you see pi, that you're pretty sure that's radians. So to convert that into degrees, we multiply that by 180 degrees per pi radians. And so we have pi radians over pi radians cancel each other, and we are left with 7 times 180 divided by 9. And so we can go to our calculator. Seven times 180 divided by 9. There we go, 140 degrees. I hope that's one of our right answers. Yes. Our correct answer is D. Next, a circle has a radius of 10 centimeters. What is the arc length of the circle described by an angle of pi radians to the nearest tenth of a centimeter? Well, for that, we have our arc length formula with this S equals R theta. And that's going to be our arc length and that's equal to our radius times our angle in radians. So angle and radians. So we're simply asked the arc length. What is the arc length? Well, that's going to be S is equal to our radius. And what is our radius? 10 centimeters. So we put 10 and times our angle theta, which is going to be in radians. We have pi radians. So it's going to be 10 times pi, and that's going to be approximately 31.4 centimeters. So our correct answer is D. Next. 5. The diameter of a large pizza is 14 inches. If pizza's cut in 8 equal wedge-shaped slices. So here we have this large pizza here. And we are cutting this pizza into 8 equal slices. And here's 1 cut, 2 cut, 3 cut, 4 cuts. We have cut the pizza now into 8 slices. And so if we cut it equal slices, we're talking about the perimeter of 1. So we got this slice here, I'm outlining in red. And our diameter is 14, so each of these sides is going to be 7. And then using the arc length formula, we take our angle, where our angle in radians here is going to be 45 degrees or pi over 4 radians. So our arc length of this piece is going to be radius 7 times pi over 4. So 7 plus 7 plus 7 pi over 4. So 7 plus 7 plus 7 times pi over 4. So we get about 19.5 inches. So 19.5, yes, answer choice B. Next. 6, in a 30, 60, 90 right triangle, if the short side of the triangle measures 5 feet, what is the measure of its hypotenuse to the nearest tenth of a foot? So here we have a 30, 60, 90 right triangle, and I'm going to draw this not super accurately, but something like this. So we'll say this is our 30-degree angle here. This is our right angle in the lower right, and then we have 60 degrees. Okay, if the short side of the triangle measures 5 feet, so we say 5 feet here, what is the measure of hypotenuse? So we want to find this thing here. Well, going back to our ACP formula chart for a 30, 60, 90 right triangle, we see that articulated right here, special right triangles. So 30, 60, 90 sides are represented by, respectively, opposite the 30-degree angle, we would call that x. Opposite 60 would be x squared 3, and opposite the 90-degree angle would be where is that? Oh, here. Got to get to the test. There we go. So this would be x, and this other side here would be x squared of 3, and this long side is going to be 2x. And so since x is 5, we have 2 times 5 is equal to 10. So 10 feet is going to be our length of our hypotenuse. Next, 7. For the right triangle shown below, what is tangent theta? Well, tangent is going to be opposite over adjacent. ADJ. And that's going to be, in this case, our opposite is 12. And our adjacent is 6. So we have 12 over 6. And 12 over 6 will simplify to 2. And that gives us A as our correct answer. For the right triangle shown below, what is cosine theta? Okay, what is cosine? Well, cosine theta is going to be adjacent over hypotenuse. So cosine of, in this case, well, we have our hypotenuse is 12. And my gosh, that probably is going to be D. Let's make sure we have this. Well, so our adjacent side, which we don't yet know, let's try that out. Okay, we get A squared plus B squared equals C squared. but c squared minus a squared equals b squared. C squared minus a squared equals b squared. So 144 minus 81 equals b squared. And 144 minus 81 is 63. So 63 equals b squared, and therefore b is going to be equal to square root of 63. So our cosine of angle is going to be square root of 63 over 12. Answer choice D. Quite an easy problem. In right triangle, if sine theta is 2 over 3, what is cotangent theta? Well, let's go ahead and take sine is going to be our opposite over hypotenuse. And so we can just draw this out on the right. Here we have an opposite of 2. See if I can get that a little more vertically oriented. And not much better, but I'll have to do. Okay, 2 is our opposite side. And then our hypotenuse is 3. So here we have 3. So 3 equals our hypotenuse. And what we have is our theta is right here. And so if we find this side here, well, it's going to be c squared minus a squared equals b squared. C squared minus a squared equals b squared. So that's going to be 9 minus 4. So we get 5 is equal to b squared. So b is equal to square root of 5. So that's going to be adjacent equals square root of 5. Well, tangent, cotangent is going to be reciprocal of tangent. So instead of 2 over square root of 5, our cotangent theta is going to be equal to square root of 5 over 2. Answer choice A. Next, in a right triangle, if cosecant theta equals 17 over 5, what is sine theta? Well, going back to our ACP formula chart, oops, yeah, it'll be right here. We have cosecant is reciprocal of sine, and sine is reciprocal of cosecant. So what we need to do is sine theta is just going to be the reciprocal of this ratio of 17 over 5. So we're going to get 5/17. Where is that? Answer choice A. Next, what is secant 2 pi over 3? Well, secant theta equals reciprocal of cosine theta. And 2 pi over 3, we can look at our unit circle. So 2 pi over 3, our cosine is x, right? That's our x. And our sine is y. So cosine 2 pi over 3 equals negative 1/2. Okay? Cosine 2 pi over 3 equals negative 1/2. So secant of 2 pi over 3 is going to be the reciprocal of negative 1/2, or so we'll have negative 2 over 1, which equals negative 2. So our correct answer choice is B. Next, 11. What is tangent of 225 degrees? There are so many ways to do this. You can go to your Unit circle, take a look at that. One thing that I will take the opportunity to do here is just plugging this in the calculator. Why not? So tangent of 225 degrees. So let's say tangent of 225. Now, if your calculator is in degrees mode, you would just press enter and be good, but we're in radian mode here. So I'm going to be sure to inform the calculator that I don't care if it's in radian mode, use degrees. And so we get the tangent of 225 degrees equals 1. So that is our correct answer. It's choice C. Next, a sine theta equals 1/2. Find the acute angle theta that satisfies the equation. So we have sine theta equals 1/2. Well, what we're going to do is eliminate the sine by taking the inverse sine of both sides. So inverse sine of sine theta is going to be simplified to just theta. And so we're ended up with theta being equal to the inverse sine of the other side, inverse sine of 1/2. And from the unit circle, you can see that right here. Where do you see sine equal to 1/2? Pi over 6, or 30 degrees. You have a calculator you can use. Inverse sine of 0.5. What do we get? Well, this is going to be our radians. Let's just multiply that by 180 over pi. Your calculator, I have you put this in degrees most of the time. So we get 30 degrees. So our answer is going to be theta equals 30 degrees. And there we have it. Next, 14. Cotangent theta equals 1 over square root of 3. Find the measure of the acute angle that satisfies the equation. Well, again, we can just say cotangent -1 of 1 over square root of 3. And we're going to get, in this case, we have radian measure. So let's just go ahead in our calculator. Again, a lot of ways to do this. But put in cotangent -1 of, let me make sure I get this right, 1 over square root of 3. 1 over square root 3. Okay, and again, we're in radian mode, so we're going to multiply by 180 over pi. There we have 60 degrees. And 60 degrees is pi over 3. Right, same place, pi over 3. Or we could just take in our calculator, we could say, what is pi divided by 3 radians? It's going to be 1.0472. Correct answer all the way. Next, 15. Solve for the unknown to the nearest tenth. Well, here we want to find this y. We got an angle here, 58 degrees, and so opposite 58 degrees we have 31. That is our opposite. Y down here is going to be our adjacent. So that we have the tangent of 58 degrees is equal to our opposite side, 31 over y. Or better yet, our reciprocal ratio, cotangent 58 degrees is equal to y over 31. And cross multiplying 31, y is equal to 31 cotangent 58 degrees. So I'm going to put in here 31 times cotangent 58 degrees. And we got to put degrees in because we are in radians in this calculator, right? So 19.37. Closest by far to answer choice D. 16. What is the measure of reference angle for an angle whose measurement in standard position is 315 degrees? Well, what we're trying to do is find the smallest positive angle to the x-axis. That's all a reference angle is. So if we have an angle, I'm going to draw a circle here. There's our circle, kind of a crude circle, but it has to suffice. Okay, so we have this 315 degrees. We start over here to the right. We go all the way around 315 degrees to here. Okay, and there we go. 315 degrees. Our reference angle is going to be this thing right here. To get that, we're going to take 360 degrees and subtract out 315, and for that we're going to get 45 degrees. That's going to be answer choice B. Next, what is the exact value of the tangent of negative 17 pi over 6? One thing you could do with this is you could convert this, if your calculation in degrees, you could convert this into degrees. My calculator is in radians, however, and so I'm going to just enter this as is, negative 70 pi over 6. So I go in here and put tangent of negative 17 pi over 6. And we get 5.57735. So definitely not a negative number. And I think it's going to be this one right here. Square root of 3 over 3. Yeah, this one here, A, is bigger than 1. Let's just be sure. Okay, Control Enter. Square root of 3 over 3. We should get 0.57. Yeah, that's it. No doubt about it. That's our correct answer. 18. Maybe the hardest one on this test. If cosine theta equals 5/13 and sine theta is less than 0, what is cotangent theta? Well, here, a cosine is going to be adjacent over hypotenuse. And sine theta is less than 0, so your adjacent is 5. Your hypotenuse is 13. So something like that, that's 13. So 5, 13, and we have a right angle. We need to find our opposite. So here we have our adjacent. We have our hypotenuse, and we have our theta here. So we're going to get something over 5, or negative 5, whatever. So to me, a cotangent is adjacent over opposite, or adjacent's 5. So I don't think D or A are looking too good. What we have to realize is that sine theta is less than 0. So what we're going to have is square root of 13 squared minus 5 squared, which is going to be square root of 144, or it's going to be, in this case, plus or minus 12. You solve using the square root. And it's going to be minus 12, and the only way we know it's minus 12 is because sine theta has to be less than 0, meaning that in this instance, our sine has to be opposite, which is negative 12 over 13. If this is positive 12, it wouldn't work. And so cotangent theta is going to be our adjacent 5 over negative 12, which is going to be answer choice B. Next, 19. An arc of circle radius of 6 kilometers has a length of 4 kilometers. To the nearest 10th degree, what is the measure of the angle that describes the arc of the circle? So we have S equals R theta, and we're given our arc of 4. So we have 4 is equal to a radius of 6 times theta. And if we solve for theta, theta is going to be equal to 4 divided by 6, which simplifies to 2/3. So that's going to be 2/3 radians. So what are we going to do? Are we going to just bubble in the, see, to the nearest 10th of a degree? Well, this is not degree, first of all. This is radians, right? So if we have 2/3 radians, what do we have to do with this? We have to convert this into degrees by multiplying by 180 degrees over pi radians. So 2/3, I'll put in parentheses, 2 divided by 3 times 180 over pi. So there we have 38.2. So theta is equal to 38.2 degrees. So you can put this in here in 38.2. And so we put in 3, 8.2. Okay, the last one, problem 20, what is sine 72 degrees? Well, just put in sine of 72, and again, I'm still in radians, so I'm going to put degrees here. So you have, I think it's to the nearest hundredth, so that'd be 0.95. So 0.95, and you can just put in 0.95. 0 is inconsequential, so that's the nearest hundredth place. 0.95. This, I hope, was quite helpful. Our next test is going to go over a lot of the same stuff, but include more of like distance, practical use of that. So, trigonometric ratios. So, as always, I hope this has been helpful to you. Good luck, and thanks for viewing.